In this lecture, we'll talk about the trend line and how to find a trend line using the OLS formula. So the setup is as follows. We have a sample from a population of size n. We have two measurements for each sample point, meaning that we have x data and y data. As a simple example, let's say that we look at a sample of students that take an exam. And for each student, we look at the number of hours they spent on the course. That's going to be our X data. And as our Y data, we look at the result on the exam. So we have some data, x1 through xn, the time spent on the course, y1 through yn, the result from the final exam. In this case, there is a clear causation from the x data to the y data. We expect the value of x to influence the value of the y data. And we would expect that the more the students study, the higher will be the result on the exam, keeping other factors constant. So here's a particular sample that we can look at. I have in this case 9 observations, 9 students. So for example, the first student studied 109 hours in total and got 61 out of 100. This is out of 100. We have one student who studied a lot. The third student studied the most of these and got 97%, while the fifth student is the one that studies the least. So when we have data on x and y like this, we can create a scatter plot. A scatter plot simply puts a point into a Cartesian coordinate system with the coordinates equal to the x and the y value. So for example, for the first student, x1 was 109 and y1, the first student, got 61 points. So we can put this as a point into a coordinate system by simply doing x-axis, y-axis, and putting a point here. This represents this point, 109, 61. If the coordinate going down on the x-axis is precisely 109, and the coordinate going to the y-axis is precisely 61. So this point represents the first observation. And then we simply put one point into the coordinate system for each observation. Excel is very good at that. You can just mark the data like this and ask Excel to insert a scatter plot like this. So the point to the left, this one right here, that represents the student that studied 98 hours. So that's the fifth student. While the point way to the right, that's the one with the highest grade and also the most time spent on the course. That's the third student. So given a scatter plot of data like this, we can add a linear trend line. A linear trend line is simply a straight line that fits the data as well as possible. So you shouldn't think about it as there being exactly one trend line, simply because the notion of fitting the data as well as possible is an imprecise concept. But the idea is simply this. We have a scatter plot with x data and y data. Each point here represents one sample point. And we have some kind of notion that it's the x variable that explains the y variable, then simply finding a straight line that fits these points will be a trend line. Maybe that's not particularly straight. Let's try again. Something like that. That will be a trend line. Excel actually knows how to add trend line to data, and it can do more than linear trend lines, but for now let's focus on trying to find a linear trend line. So we just right click one of the points, and there is an option which is add trend line. And here you have trend line options. We are going to focus on the linear one right now. So here you can see that it has added the trend line. It's this dash straight line that seems to fit the sample points quite well. So the trend line is a straight line, which means that we can represent it with a linear function. A linear function has a slope and an intercept, and this trend line will have that as well. So if we go back, we can simply describe the equation of a linear trend line as a linear function relating y and x by writing y is equal to b1 plus b2 times x, where b1 is the intercept of the trend line and b2 is the slope of the trend line. So if I draw a new picture here with just a fewer sample points like that, I add a trend line, then this value here, that's the intercept. B1 is the intercept, and B2, let's even write that, this is my trend line. B2 is the slope of the trend line. So the interpretation of B2 is this: if x increases by 1 unit, y increases along the trend line by precisely b2 units. So keep these apart. The trend line has an equation y is b1 plus b2x, which is valid for all x's. The points, the data or our observations are points such as this one, xi, yi. That represents one sample point with this x coordinate and this y coordinate. Since I typically have quite a lot of observations, it's not possible to find a trend line such that all these points are on the line. Well, not necessarily. They could be on the trend line by fluke. So if we go back to Excel, we can actually ask Excel for the equation of this trend line, figuring out the slope and the intercept. So just right click the trend line, format trend line, and you have an option here which says display equation on chart. So here's the equation. We can see that the intercept in this case, that's the second number here, minus 8.33. So this will actually intersect the y-axis below the origin. If I continue with this straight line going down like this, it'll actually go below the origin. And it has a slope of 0.6. So that means that along the trend line, when x increases by 1 unit, y increases by 0.6. So that means that along the line, 1 more hour of studying for the course will increase the result on the final exam by 0.6. So the next question then is, where did Excel get these numbers from? How did it come up with a slope of 0.6 and an intercept of minus 8.33? Well, the answer is that it used something called the OLS formula. So we simply say that We use the OLS formula, where OLS stands for ordinary least squares, if we calculate the intercept and the slope of this trend line using specifically these formula below. The slope is calculated using this formula, and the intercept is calculated using this formula. These together are called the OLS formula, even though there are actually two of them. The particular trend line that we get from using these formula is then called the OLS trend line. So the OLS trend line is just one possible way of finding a trend line, but it's typically a trend line that looks pretty good. Let's begin by looking at the OLS formula for the slope being the most important one. So the formula for the slope is sum, and I tend to use the convention that whenever the sum goes from I equal 1 to n, I just don't write it. Saves a lot of time. So this is the sum. I go from 1 to n, xi minus x bar, yi minus y bar. That's on top, and on the bottom we have xi minus x bar squared. So knowing about sample moments, the sum in the numerator looks pretty much like the sample covariance between x and y, and the sum in the denominator looks pretty much like the sample variance in the x. The only thing that's missing is the 1 over n minus 1. But we can of course add that as long as we add it to both sides. So I can add 1 n minus 1 over here and 1 n minus 1 over here. That's not going to change the formula because I'm multiplying both sides by the same number. So now we recognize the formula for B2 simply as the, well, let's not write the text, as the Sx, y, the sample covariance between x and y, divided by the sample variance of x. This also means that you cannot swap the x data and the y data. If you swap the x data with the y data, then the result for B2 will be different. The sample covariance will not change, but if the y data is on the x-axis, then you're supposed to divide by the sample variance of y, and that will be a different result. So keep in mind, we do not treat the x and the y variable equally. We have this concept that it's the x variable that explains the y variable and not the opposite. So let's go ahead and see if Excel has calculated the the OLS slope and intercept correctly. So we need the sample covariance, and that is covariance S x data, comma, y data. And we need a sample variance in x. We don't need it for y, and that is var.s, and just for the x data. Then we can calculate B2 simply as the ratio of these two. So sample covariance divided by sample variance in x, and hopefully that comes out to be 0.6, and it does. 0.6005, the same result as we got here. To calculate B1, move back, we need the average of the y data, the average of the x data, and also B2, but we already calculated B2. So let's do that. So we just do average of the y data here. Then we do average of the X data. So let's calculate B1 then. And we get that from the average of the Y data, that's right there, minus the average of the X, like into B2 times the average of the X data, right there, and that should come out to be minus 8.33 something. Finding the equation of this trend line is sort of the or sort of a fundamental idea in econometrics, and it's something that we do quite a lot. Both of these ways of finding the result for the slope and the intercept are kind of inconvenient. On the one hand, we had to draw a scatter plot, and on the other hand, we had to calculate quite a lot of data. Excel obviously can give you B1 and B2 right away without going through the scatter plot, but there is a slight trick to it. So the trick is this: start by typing, let's say, B2 and B1 like this. I'm just gonna center them for simplicity. Then I want Excel to return the result for B2 in this cell, G21, and B1 in this cell. Yes, it's a little bit weird because it's kind of backwards. It gives you B2 the slope first and B1 the intercept last, pretty much just like it does here in this equation. So to get these numbers, you have to highlight both cells like this. Then you can simply type the function, which is linest, linear estimation. The hint tells you what to do. The known y's, so just highlight the y data. And it's important to do the y data here. That is the data that we think is explained. Then you can do the known x's right there. The constant simply means you set it to true if you want the constant to be calculated normally, and you set it to false if you want the constant to be forced to be equal to 0. So we want to calculate it normally. The statistics, we can just simply do false on that. We don't need additional statistics right now. So this is all you need to do. And the final thing you have to remember is that whenever you want Excel to return two numbers, you have to hold down the Shift and the Control key and then hit Enter. Then it'll give you two numbers. And you can see that those are precisely the same numbers that we calculated here, here, and B1 here, here, and